All right, we got the volume fixed as well.
Oh, okay, cool. Let me check my levels. Okay, so what I'm doing is I'm recording the screen and my voice. So hopefully that doesn't bother anybody. I'm not actually going to be able to record what you say anyway. But I'm doing this because what I'm trying to do is take all these presentations that we do and put them on YouTube so that if you're not in the room, you don't just miss out on what exactly it is that we're talking about. So, for instance, I have a 2-hour presentation on Charlene that I have on YouTube that you can go see if you just Google Charlene or you look at the 5-Minute Modules channel. So now I'm not going to talk to you about
The
Charlene
broadcast
for 2
is now
hours.
starting.
So, it's a win-win situation. So, what I'm going to do is talk about, our general sort of plan. So, this diagram, if you can see it, is basically all of field processing stuff from raw data to submission. At least sort of how I think about it. So at the top you have data acquisition, it comes into a drive, you do processing, it shows up in storage, that affects your planning for the next day, and you're stuck in this sort of circle, and you live in this circle for a while. The sheet manager towards the end will start looking at it from a sheet perspective, doing rough cleaning and troubleshooting and QC checks and stuff, and then you're living in this circle for a while if you're a sheet manager. And then at the end you go through this sort of like parallel mode where you're worried about your DR, you're worried about final cleaning, you're worried about all the troubleshooting and stuff that comes with looking at the sheet from a sheet perspective. And then you have a submission thing, how do we get this right, and then you submit it. So most of what I've been doing for the last 2 or 3 years is focused on just this cycle. How do I make the cycle make more sense, be more intuitive, and how do we take the human out of the loop where it's appropriate? Does that make sense? If you guys have questions or something, you can just shout at me. It's fine. We can work through stuff. Like if you have any ideas for stuff that I've left out here, we can talk about that. So, if you look at these guys, this, for the most part, should I have done this in real time? This, for the most part, is Charlene. So Charlene is this stuff. Take this, we'll do this, it'll look better. Okay. This is Charlene, right? This whole cycle. And I guess also including the storage. Maybe I'll do this. And then affects your planning and whatever. This over here, I do have a point I'm going to make. Once I fumble through this. Here we go. Alright, this is SHAM. Something else I've been built that I'll talk about. And then this is, wait for it. Oh man. Almost. Okay, this is machine learning efforts, and I'll talk about that. And this is automating DR stuff. This I'm glad I'm recording this. This is more of the same machine learning stuff. And then this last thing is sort of a combination of a bunch of stuff that we're doing. Right, I like to think that Charlene eases with submission. There's like this letter transmitting data thing. There's the beyond compare stuff at the branch. There's other random stuff. And then what you see is at the very end, all you're left with is this transparent. Right. Yeah, this. Okay, I'll do this. So these elements, right? It's the same thing. QC and troubleshooting. And that's where having a human in the loop is important. So my goal, personally, with the stuff that I'm doing, is to have people in the field worry about operations and also worry about QC and troubleshooting, and then try to automate the rest. Frees up more time, gives you more time to worry about operations, which is sort of like, in a lot of ways, the harder aspect, because there's scheduling and boats and people and lots of stuff that you can't really plan for very well, and then problems arise and you have to deal with them. And so take the easy stuff that can be automated and take that out, and just leave you with the stuff that's important for a human being to do. Does that make sense? Where are those heads? I see some heads. Alright. So, Charlene. So we can talk about Charlene first. We go over here, run Charlene. What I'm going to do with Charlene, again, it takes like 2 hours for me to talk about all of it. I'm just going to set it up, I'm going to run it real quick, and while it's running I'll talk about the important elements. Okay. Is this still showing? Yeah. Okay. So I'm just going to take this, I'm going to do an RTX SBET, I'm going to do a raster surface, forget tides, that's old school. We'll do some grid QA or something. And let's do the 2018 support files, this. Okay. So running, it's running. Alright, so it's going to go through the pre-checks. You guys are all probably familiar with this. There might be some branch people there who haven't seen this before, but whenever somebody comes to me and says, hey, Charlene didn't work because, I don't know, I don't know why, right? Here's an error message. And I take it and I go, okay, well, it's probably because you have pause files from one day and multi-beam files from the other day, and so I'll just build a check to make sure that you're not doing that. So I have like 30 of these checks now that basically make sure that everything is correct in Charlene such that it will work and not generate an error. So go in here and pick these options. So what's new in Charlene, I took all the stuff that people have found confusing and I built a dialogue that sort of explains it. So I had a lot of comments about these TPU values down here at the very bottom. So how do I take those things and make them a little bit more easy to understand? So I built this TPU values box, and you basically just pick the mode, right, and it tells you what to put in for the most part. And this is like FPM guidance. Alright, so it's running. What I've done here is I've taken what is sort of the new way of processing data, which is using an RTX SBET. Everything's set with delayed heave. It's going to run the SBET first. It's going to process in Keras 11. So Charlene now is going to run in whatever the latest version of Charlene or of Keras you have installed. So I've got 11 something. So it's going to run 11. And you'll see there'll be a new reference to georeference bathymetry. So it's going to go through the whole georeference bathymetry workflow. What I thought was important is to make Keras 10 and Keras 11 transparent from Charlene's point of view. So you can see there's no georeference bathymetry option here. Because all georeference bathymetry is taking all of these things and smushing them together into one process so that you don't have to tell sound velocity correct and compute GPS tides, that you're using delayed heap. It's one process, so it knows everything that's coming into it. What else did I do? I removed a lot of the stuff that is able to be discovered through looking at the data. For instance, your reference point, I don't ask you for that anymore. I don't ask you for a projection. I don't ask you for probably some other things that aren't coming to mind immediately. All I really do is I get the stuff that I can't really get from data, and I ask you to enter that. And so it's just these things, for the most part. SBETs have been a bit of a sticking point. So some of you guys are probably from the Rainier, right? Yeah. So we've had a lot of problems with SBETs and bandwidth, satellite internet connections. Currently, the way it's set up, when you use the batch processor, which is what I'm using right now, it's not very resilient to a loss of internet connection. And the GUI is, which means that Charlene SBET processing is not as reliable as POSPEC SBET processing, which is kind of annoying because I spent a lot of time on it. So I've been working with Applanix to try to figure out why it is that the same process that you can do in two different ways is a different process, right? It should be the same process. So hopefully we get a better answer for that. The majority of your RTX dropouts that you probably see are the result of POSPEC querying in a Planix-owned server, and I think they only have like one or two of them. And so if everybody hits the server at the same time, you're going to have problems. And that's not just NOAA, that's like everybody who uses POSPEC. So they told me that they're expanding how many servers they have, and hopefully they're going to cut down on the dropouts that people are seeing. We've also had problems with, well, not really a problem. So historically, for as long as there have been SBETs, there have been solution status gaps and IMU data gaps. We still see those, whether it's a faulty cable or some other issue. And historically what you've done is you've taken your SBET, you process it as far as it goes, it fails because of some gap, you take the start or the end of that gap and you process the second SBET. So in Charlene 3, as long as it's a solution status gap or an IMU gap, it'll actually do that for you. So the way it's set up now, you very well might get multiple SBETs out of a single Charlene process, and it's just splitting that gap. So I just automated that whole routine. You won't see it in this one because I've run this data set a bunch of times. There aren't any problems here, but if you encounter problems that are so egregious that I haven't built anything to handle them, this bar will go red and it'll tell you what the error is. Hopefully in some language that you'll understand. It might be in like POSPAC speak or something. So I took out the AutoQC checkbox. It's going to run AutoQC automatically, and you'll see that at the end. And the idea there is that we're hoping in the future we're going to morph AutoQC into something that doesn't just give you a bunch of plots that are hard to read, but actually influences the processing. So would that be, interpolation or identifying whether the SBET is good or bad, and then telling you, right, something that's a little bit more interactive. That's not currently built, but what we're doing is we're setting ourselves up for when that does happen. Hopefully, at some point in the future. So, what else should I talk about that's important? The Keras 11 stuff, there was a lot that went into there. They changed a bunch of formats for things. They changed their log formats. They changed the database structure. They changed the destination file structure. So the whole vessel config, vessel day line folders, right, all that sort of went away. So Charlene sort of handles all of that and makes it something you don't really see, but it will be there. I think this takes like 15 minutes. I don't know, are there any questions about Charlene or stuff you want me to talk about? I have other stuff. It's super early, right?
Yeah.
If I was there, I would like throw an apple at somebody, but I don't have the ability to do that. Google does not have an app that lets me throw apples at people.
Throw it at the dark back of the room. Yeah.
I also can't hear you very well. This is good. This is a great format. Okay. So there's another element to this diagram that I didn't really talk about when it comes to troubleshooting, right? In order to troubleshoot, you have to understand the process. So Charlene 1.0 was like me trying to figure out how to actually do this, and it almost worked. I defy anyone to tell me that it didn't almost work. Charlene 2.0 was me trying to take Charlene 1.0 and make it actually work, and I think I sort of did that. And then Charlene 3.0 was me trying to say support Keras 11, some other stuff that's not very exciting, but also try to make a bunch of things that help you understand the process. So I've had people ask about how to understand the launch transfer drive network thing, and why are there two different modes, and what is the point of these modes. So I think this sort of explains it. You can get to it by going to, hold on a second, just copying the S-bit. You can get there by going to help and launch versus network diagram. Right, brings up a PDF. I had a lot of people ask me about, okay, you know, why are we doing delayed heave, right, if it's an ERS workflow? Well, if you check this Keras, what do I call it? Charlene Keras 10 diagram, this sort of explains the whole process in even more detail, where it's like, okay, well, the reason is because, you know, I wanted to support different reference points, and you got to back out the heave lever arm right here, because you got to get heave relative to the IMU, because attitude and depth in the .all file come from different places, and how do we know that, right? So it's like this whole, everything that we had to figure out to make this work should be in here, for the most part, I think. There's also like side scan stuff too. Right, we actually have 3 different input workflows. So I'm trying to provide information that lets you figure out what exactly I'm doing. And you get it just from here. That's still running. Where are we at? Conversion. Okay. You guys have probably already seen this. These references. I want to show you this. I'll show you the very end result. I got 4 more minutes. Well, I can show you this. So we did talk about georeference bathymetry a little bit already. So this is the Keras 11 version of that diagram that I showed you. And you can see this giant block is georeference bathymetry. And it's basically the same thing as tide, sound velocity correct, GPS. There's no GPS tide in 11 because I think they were embarrassed about that, so they moved away from it. But there's a GPS vertical adjustment, right, which makes it sound better. And there's also this total propagated uncertainty deal that we're used to. But the inputs are all the same. It's basically the same thing. Right, and then after you get it you get time series data, right? Time-stamped depths, time-stamped positions, time-stamped attitude. And at the output, you get georeferenced soundings. Something with a lat, long, depth, uncertainty, right? Soundings. Merge is in here too. Merge is just, this whole thing is merge, so you don't have to, there's no real merge anymore. Anyway, I know there's a lot of like stuff in here, and maybe it's kind of confusing. Maybe it only makes sense to me. I don't know. It's entirely possible. Sometimes you make things and you think they're clear, and then you show them to people, and they're like, "What in the hell is this?" So this very well could be one of those. Okay, finished. Cool. So one new thing in Charlene 3, when you finish, this thing pops up. So one of the big questions I had was, okay, Charlene runs. How do I even know if it did what I wanted it to do? My standard answer was, well, you just read this thing. Just read it. What's the problem? You don't want to read this? Right? Anyone can understand this. Look at all these percentages. All these numbers. Look. We all know what IIN, course leveling ended, means. That's good, right? That means it's good. Yeah. So I was like, okay, fine. I guess you probably need a summary of this. So that's all this thing is. This thing pops up, and it's a summary of that. I had 9 lines. They all converted. They all got the delayed heat from the pause loaded. They all got aspetted. Georeference. Oh, there's a warning. That's interesting. But then we create a surface. The surface is good. Here's your detailed line query type thing. And it looks good. And then what I tried to do is I said, okay, well, Keras has all these standard warnings. Most of the time people don't know what they mean, so maybe I'll try to write like what I think it means up here. And sometimes I'm going to be wrong, but I think it sort of makes sense. Some of these, this is not a good example, because this is sort of a weird error message that I don't think even makes sense or is right. So it's a terrible example, but some of these are be like, oh, here's a good one. So if you have the wrong UTM zone, it'll tell you, you know, surface doesn't cover data or something. It's super ambiguous. But what it really means is you're probably choosing a projection. It's different than your source data, and so it can't find data, even though it has data. And so I just wrote that in a paragraph up here.
Hey, Eric, can you increase the zoom on your screen a bit? Either in Excel or just in your, yeah. Thank you.
Am I on a projector?
You are.
Okay.
Well, except for people, you're on the projector for advanced hydro training that are here, but there's a few people that are remoted in.
Yeah, right. Okay. Green is good, red is bad, yellow is meh. The standard. Okay, cool. So that's processing. I should mention that, right, if you look at the destination, right, Charlene creates the project, the sheet folder, all these directories. If you look at the reports, survey, separates, processing logs, vessel, day, right? We all know that. If you go in here and you look at the status report, that's the thing that popped up that I just showed you. If you look at, I don't know why I opened it again. If you look at this thing, right, it's your processing log, right? I think you guys have seen that. And then if you look at up here, there's your vessel specific log. Each new log is a tab in here. So you end up with, 20 tabs in a spreadsheet that has all of your logs. My point is that anything that I create is probably going to end up here. So if you needed to get this thing, it's just here. Okay, one one thing you'll notice if you go in here and you look at the very end, I don't know how to zoom in, but trust me when I tell you that this says database write complete. So you get at the very end your very own line in the Charlene benchmark database, which is right here. So here we are. This is what I just ran. This is a server here in Silver Spring. So we're working towards this being the ships, our ask of the ships for metrics and stuff. So you'll see every time you ran it, they'll tell you, right, size of your multi-beam files, and here's your linears, here's your squares. This is a well-known text export of a shapefile, so I can actually load this and get the extents, a GIS view of the work that you did. And here's all your settings. So I'll use this. If you tell me you have problems, I don't have to ask you if you created an SBIT or not. I can just look here and see what you did. So there's like times and stuff. We're hoping this is going to be more of an official thing later, but we're sort of working on the infrastructure for collecting this and showing it in an intelligent way. Okay, last thing I wanted to do was, where's Charlene? This. Okay, so if you go to create offset report, this will be a bad example because this HVF is set up in a strange way, but what this is doing is it's taking a multi-beam file, a pause file, and HVF, and it's reading offsets from the pause file, offsets from the .all file, offsets from the HVF, and your flags and stuff. And it's telling you if those things make sense. So this was even on the agenda roundup for this advanced hydro training thing. Someone said, like, hey, can we talk about HVFs and what goes where and why? So this doesn't create an HVF for you or tell you how to create one, really, but it does tell you if what you've done is right. And you should be able to take this and, like, from one boat and use it to create the HVS for all the boats, right? Because they're all basically the same. This thing will tell you, right, your reference point is at the transducer. You're using a 2040. So you have 2 SVP entries, and SVP2 needs to be the same as the receiver offset with X and Y flipped and the sign reversed or something. So that's all in these notes. This tells you everything that you need to do. So I don't think this ever really existed in any form. I think we've always just said, here's your sonar, and here's the installation, and we'll do an HVF for our acceptance, and then we'll just give it to you. And there you go. And so this, I think, makes it so you should be more comfortable with creating these things. Or at least making sure they're good. All right. Any questions about Charlene? All right, we know how this works. I don't think I wanted to talk about anything else. Okay, cool. So what else did I say I was going to talk about? Oh, this SHAM thing. So I think some people didn't know this existed. So if you look in Pydro, there's this shoreline attribution machine thing that I built. Basically all it does is, it's sort of a West Coast thing, where you would go out and you would get an observed depth and an observed time, right? And you'd use those two things to then build the entire attribution for a future, because you know it's a rock, and you know your tides, and so you know what your valso is, and you know what your wattlev is, because you've got this separate, all of that stuff, right? It's just a rule set. So I took the rule set, programmed it, and it does all that. Here, I'll just show you. It's probably the easiest way to do it. It's not perfect because there's a lot of weird feature things that we do sometimes, so there might be some feature types that aren't supported. But if I go traditional tide, which is, well, the traditional way of doing shoreline verification. And you pick a 000 that has an observed depth. Where did my thing just stop? Nope. Did I lose you guys?
I still hear you loud and clear.
No, they dropped off. Can you hear me? I can't hear you anymore. Okay, you can still hear me? As long as you can hear me, we're good. Somebody thumbs up me. Okay, cool.
Here's now?
Yeah.
Okay.
Okay. So SHAM. So traditional tide is how we do features generally. You go with the backpack, you get a height in a rock, you know your GPS position, you fill in observed depth, observed tide. Sometimes you get a rangefinder, blah, blah, blah. So if we take this, and we take Takari. Why did I do that? Let's do this. Take this, we take our Takari file, and then we fill in this metadata, right? You need this for like, where does that go? It's in source indication? I don't even remember. That's why I build these things, because I don't even remember this stuff that we've figured out for ourselves. Anyway, and if I run this, what it's going to do is it's going to take the Takari file, it's going to pull out a tide according to the time in the feature. It's going to generate those separation values, and it's going to build a feature. Let me pull up where it went. In here, nope, in here. And it's going to build this new feature. So if you look at the log, these are all just sort of like make-believe things, so they're probably not going to make a whole lot of sense, but right, it finds the depth. I put in a waterline of 0, I think. Here's the Takari answers for separation values. Here's your final depth according to those separation values. Here's your tidal adjustment. We create the depth, right? We know it's shoreline construction, so we build the SOAR and sort out all this stuff. So it builds all that stuff. Should be everything. I could look at it, I guess. Probably makes sense. Close. Do not save. Take this. I go new. There might be a support file conflict or something. I'll keep up with this. If I look at one of these, and I look at attributes. Let me see this. Yeah. Right, Valsau, Watlev, Kwasau, Soren Sordat, Texau. If I'm speaking gibberish, it's because it is sort of. Everything should have a height. Yeah, even piles, I'll give you a height. And that should match what's in the log. Somewhere. This thing's sort of focused on obstructions and rocks. And I don't even have any in here, so this is a terrible example. But with rocks and obstructions, there's more information here, and it makes a little more sense. And I'll fill in description and remarks for some of these. I should probably expand it. I haven't gotten a lot of use out of people using it in the field and telling me what is good and what I shouldn't do. So if you guys do use it, I'd love to get some feedback, because so far this is sort of just my take on it. Cool. That's that. What else did I have in here?
Does anyone use this on Rainier Fairweather? Not yet? I'm sorry, you have on the Fairweather? Okay.
Yeah, it came about when we had the Velodyne, and we were trying to figure out how to tide correct Velodyne. Oh, I guess I didn't even really talk about it. So the other thing it does, and this is sort of the future of how we expect these things to actually work. We don't have a great hardware solution yet, is to not tide correct, but SBET correct. Right? If I take this, and I go in here, and I pick a 000, and I pick what is probably a terrible SBET example. There's a theme here. All my example data's sets aren't very great. If I take this and I run it, yeah, there you go. What it does, it'll take the observed time in the feature, pull out the altitude of the SBET at that time, use VDatum, take VDatum and get the mean low water, high water separation values, build final depths according to those, and then the same thing. It's the same thing. It's just I'm getting height and separation from SBET and VDatum versus height from you in the field and Takari tides. So it's the same workflow for the most part. Oh, we also did mention the whole rock islet thing. Since I'm getting mean high water separation values, I do that automatically. So yeah, I put in here, it says will auto-magically convert rocks to islets. Don't worry about islets, it just does it. If you build an islet in here, I'll assume that you found an islet, which you won't.
And does that have the new 0.1 differentiation updated into it?
Yeah, I put that out like 2 days ago.
Okay.
Does that include the Great Lakes? So the Great Lakes thing is like low water datum in 0.1?
Yeah, it does, but it's a funny thing because the Great Lakes, there's never actually going to be a rock awash in the Great Lakes per this, and that's something that we made CD aware of, and they said, yeah, that's fine.
Okay.
So I don't know if they were aware of that initially or not, but we brought it to their attention, and they don't seem troubled by it.
Okay.
So,
well, that's what I do, so that's good. For the purposes of my recording, we're talking about the Great Lakes low water datum thing, which I don't know too much about, except that it affects this rock islet classification, blah, blah, blah. It should all be right in SHAM the way it is now. Okay. Everybody gets the SHAM thing? We're good. Everything is good. So for a while, this machine learning thing, I don't have a whole lot to say here. For the last year or so, I've been building this network that should recognize good and bad bathymetric data. And I had some success, but it wasn't all that great. Mostly because I couldn't figure out how to attach it to a Keras project very well. That didn't involve a lot of like translating back and forth, blah, blah, blah. The short answer is that Keras has this new auto-cleaning thing. And so instead of trying to build around, we're just going to try to validate what they have and tweak it. You could think of that as being something that we're experimenting with that gets rid of the idea of rough cleaning. Rough cleaning being you going through and cleaning out fish or like super obvious problems. Not final cleaning, but just rough cleaning. So hopefully we're getting something that'll help with all of that. They're supposed to come out with a beta here not too long, and we're going to be involved with the beta testing of it. So this auto DR thing. So I've built something that takes a finished project and generates a bunch of metrics. Right, like in the same way that I have this database that tells me all of your linears and squares, right? You need like a sum total for your DR to explain. So I took this logic and I applied it to like a sheet level, such that I get all the metrics that you need for the DR. And then what I did was I built this thing here that takes in your final main scheme surface, your final crossline surface, your shapefile, or your sheet extents shapefile, and some charts. And what it'll do is it will automatically build all of the screenshots you need for a DR. And it's not like, it's not there quite yet. Here, it pops this up. So what it's doing is it's going to like basically do all the stuff that you do to make DR screenshots. It's going to take all of the surfaces, build tips, take tips, combine them in different ways, crop out specific parts, and yeah, in the end you get something like this, right? You get like a screenshot with your coverage overview. And it's actually a better screenshot than something you can get from Keras because it's not a screenshot. It's like a somewhat, I downsample it so that's not like a giant file. You don't have like a, 50 meg TIFF just for coverage overview, right? Who cares?
How does it decide, I guess, how tightly to zoom in on that coverage?
That's a constant. That's hardwired in the software. This is like, well, there's a few things. So if you actually look at the, oh, I think it already got rid of it. This one? No. If you look at the TIFF export from Keras, it's a little bit off center, so I still haven't fixed that quite yet. But right now it's just like, I think it's like 20% buffer. It's just sort of built in. There's your sheet limits. None of this looks good because I haven't gotten to the part where I worry about making it look good. This is very like bleeding edge. I'm just sort of working on it in the background. It's going to take all the cross line. It's going to do the compare grids, the jack road, and it's going to give you all the statistics, and then it's going to give you the cross-line comparison files with all the images, right, with its color-coded things. And then it's going to do the same thing for junctions. And then it's going to take all of the what's left. I don't know. I'm sort of working through the whole DR thing and just trying to automate as much as possible. The idea is the same. It's the same idea as this, right? In the end, you're going to get just section 4, the one that's like data quality.
Yeah, that's my major question.
Right? I only want you to write that section because that's the only part that is opinionated and requires your scientific mind to figure out. Everything else is just automatic. So this will just fill out the XML DR and you just have to worry about that one section. I should mention it takes a very long time, especially if you're working with like a surface that's, half a terabyte or something, some ridiculous surface. This is going to scale. There's some downsampling in the front end, but it's still very much tied to the size of your files. So this probably will end up being something you'll just run overnight, and then in the morning you'll get a DR. Yeah, and some of these images are a little screwed up. Right, so you zoom in on max deviation. You end up with a ton of files. Does that make sense? Good?
Do we have a question?
Where is it pulling the, do you have to provide it, I guess, background file, the charts, the cross-line comparisons?
You'll probably have to repeat whatever was said. I couldn't hear you.
Yeah. Do you have to provide it with the cross-line files and the chart background, or does it go gather that up itself?
Right now you have to provide it. I could make, so there's still some like play and like what files you might use. I don't know. It sort of ends up being like I'm just gonna ask you where a couple files are. So I probably won't automate that. I'll probably still ask you. The rest of the stuff that gathers metrics and things for your project, that I don't ask. So I will, in the course of doing that, find your final surfaces anyway. So I don't really know. There'll be an interface. It won't look like this. I mean, this might run in the background, but there'll be like, just like SHAM and all the other stuff, there's interfaces.
Okay, thank you.
I think it's, oh, there's the junction. Yeah, so some things I haven't quite figured out. I think junctions are sort of, I think we're still doing them, but they're sort of going away, which is good because I had a few problems with this part of it. But I think I got to where it actually builds the overviews somewhat correctly. It's like right here. Where is it? Whatever. So that is the DR thing. I really want to show this. I hope it there it goes. Alright, so that moves on to junctioning. I gotta work out this magic with charts. It's the thing that Keras does that makes the border go away. I think that's built into like, it's built in somewhere, so I just gotta figure out where that is. Alright, but it's just doing compare grids on the junction overview, and then you get all the metrics. Oh, I didn't talk about the metrics. So the, which one is it? I need to rename them, I guess. Somewhere in here is the, yeah, this stuff, like the stuff that comes out of compare grids. Anyway, short answer is all the stuff that you put into a DR. Okay, I think I hammered that home. Yeah, so there were a few other things in Pydro that I wasn't involved with that are various things that I can talk about. So there's this letter transmitting data thing that I think people are using, possibly. All this does is it gives you an interface, right? Like for instance, if I'm looking at the thing that I processed today just in front of you, and I look at these values and it produces a manifest and PDF, and I hit create, runs the thing, and in the end, oh, I'll talk about this, it gives you a PDF, and it's blank. What happened? Well, you just have to go over here and you have to set it to trust the document so that it shows you the information. And then you get the letter transmitting data that you use to submit. And then, at least in my mind, more importantly, I close this, you get the manifest. Alright, so this is cool. You can take this thing, I think this is the Beyond Compare one. You can take this thing and you can, when you receive the drive, you can go through and you can actually see that all these files exist, and here's the file size and manifest everything in there, and all the information about it lets you verify that it exists and hasn't changed. Technically it doesn't cover every situation in which something could change, but it is pretty good. There's a reference to this XFDF thing. This is just like if you have multiple files, you can use this Python thing, this PDF TK, which lets you combine multiple files and you get this thing out. Did I lose it? Oh, there it is. Yeah. That's why there's two of these. This, if you had this installed, this PDF TK, you'll get one of these that covers all of these pages. Exciting. Okay. And then there's one other thing I wanted to talk about. What was it? It was Oh yeah, so Barry's working on this survey outlines thing. I don't know how many people are involved in using this, but he's building a whole new interface, and
I've been working with him on that. He showed me the new interface, which is just available in the developer mode of Pydro only, unfortunately. But it is a lot better than what Gordon had built before.
Yeah.
His biggest hang up now is he's still stuck on variable resolution.
Yeah.
Unfortunately, this interface doesn't work very well. So I would discourage people from using it until the new one comes out.
Yeah, right. Yeah, that was sort of the point I was going to make, was that this isn't what it looks like, and it's not quite ready yet.
Nope, I've been poking at him, and we're developing it.
Yep. Oh, this thing finished. Oddly enough, I'm doing all the same stuff that he's doing with survey outlines. That's how you get all these images. There he is. Here's your junction. There's some weird like offset issues. For some reason the chart's not showing up. Shield limits. Yeah, that's as far as I've gotten on that guy. So overview for Pydro. There's going to be a Pydro 19 that's going to come out pretty soon. There'll be a lot of changes in it that will not be obvious at all to anybody, including an update to VDatum, an update to a new Python environment, stuff that you don't really use but that we use when we develop. And it's different enough that when you install it, it'll actually install beside Pydro 18. So if you were to you might get two versions of Pydro, is what I'm saying, if you went to install the new one. Which is intentional because they're very different. But it'll look the same. All of this will look the same. Alright. Any questions? Does anybody have anything they want to talk about? You want to talk about RTX? I talked about RTX with the NRB guys. There was some confusion about what exactly it is. You want to do that? Should I just...
I'm looking around the room, gauging.
I have like a 20-minute thing I could do about it.
All right, Steve Moulton says let's talk about RTX.
Okay. Let me get my notes. I don't have anything visual, but I can talk about it at least. Alright. So... you have GPS, GNSS, right? GNSS meaning constellations aside from GPS and GPS, right? It's the global...
Eric, are you intending to show us something other than this extract survey outlines tool right now?
No, I don't really have anything.
Okay.
You can look at my face.
Okay.
I'll wave my hands around.
Great.
You can
All right, sorry.
All this unapproved hardware on my desk. All right. So
you don't have as much crap as Shelley does piled up. So.
Yeah, well, she's in the liaison office, so she's like stuff from like 1998 still in there.
Yeah.
Or whoever was liaison 20 years ago. So you have GNSS, right? GNSS is for long-term position correction. You have your IMU, which is for the short term. These things are balanced out through the Kalman filter, which gives you an error feedback loop. You take the two, you get a somewhat better answer, and you know if it's better because of the error. And so that drives you to a better solution. If you look at that system, right, that is what the pause is. GNSS, IMU, and some software. firmware. And that whole system, just the way it is a loosely coupled system. So that's what loosely coupled means. You probably heard that before. There's also tightly coupled. So tightly coupled is this idea of carrier phase differencing. So maybe I can do this. I wish I had like a stylus. Right? If this is you, I don't have time to draw. And that's a satellite. You. This is gonna look great in my recording. This is a satellite. Right? This distance is the pseudo range. Traditional GPS, what they do is they'd send a code on a carrier. Let's do this. So here's your carrier. Right, super high frequency, lots of changes. And here's the code. Not many changes. Low frequency. The effectiveness of this signal is determined by how many changes there are in it. Right, that's where this idea of resolution and pulse length in sonars comes from. A shorter pulse length, and there's more of these little wiggles, which lets you tell where you are in relation to the thing that you're shooting the signal at. Sort of. I don't know if I explained that very well. But so standard GNSS uses the P code and the CA code. P code is like military, they declassified it. And you get a pretty good idea of this distance. But then there's the carrier phase. Notice the carrier phase changes way faster. Right? P code rides the carrier phase to get here and back. So what if we use the carrier phase to figure out the distance between these two things? And so what you do is you say, okay, here's my carrier, here's me, here's where it's going, right? It went through 3 cycles, 2.5 cycles to get there. This thing's, I don't remember, megahertz something. This thing's a high frequency, and so these distances are super short, which means I get a really good distance. So if I check the carrier phase and see where I am in the carrier phase in relation to, right, where I am here in relation to here, I get a much better pseudo range. And that's what tightly coupled is. Tightly coupled is carrier phase differencing to get a better distance. So there's a couple ways of doing this. You can do RTK. This is just you here, and then this is your RTK station. RTK station. Right, you're sending. This RTK station is hitting the same satellite, and it's going through the same patch of sky. So if there are problems with ionospheric disturbances, things in the atmosphere that affect your range because they're making the signal like bounce a little bit, bounce around in the sky, because there's like big lightning bolts or something that's like messing up your signal. Ionospheric disturbances will be seen from the station and from you, so you can difference that problem out. Differential, differencing. You get a corrector from the RTK station and you apply it where you are. The RTK station is more reliable because it's not moving. And you're the rover, you're moving around. It's the station, it's stationary. So the differencing that you can do there is very effective. Problem is it's usually done in real time. So what you're not seeing here is the fact that this requires internet for N-trip or a radio link if you're just doing regular RTK. So if your radio link breaks or your N-trip breaks, then you lose your solution. And you'll see this a lot with even with like Marine Star, which is this over L-band signal over your GNSS receiver. You'll see this because what was I saying? Wait, I lost my train of thought. Oh, right. You'll see a solution status loss, which usually is a ramp. Like if you're looking at your altitude, you'll be like, here's my S-bed altitude, it's fine. And then you get to a point and it's just like, whoa, it goes crazy, and then it drops back down, and then you're fine. Right? If you see this in AutoQC with the S-bed troubleshooting tab, right, you lost solution here, and you regained it here, and then it was just drifting in between. So that's the problem with real-time. RTK, Marine Star, etc. There's single base. We're well familiar with single base. All you really do is you replace this RTK station. Right, with single base. Single base. And this is either a core station, something that exists already, or something you install yourself. It's a station. You get a corrector, it sees the same patch of sky, blah blah blah. You do a differential solution in POSPAC. It loads the TO2 data from that receiver. It loads ephemeris, which is satellite positioning, and then you get a corrector post-processed. It's the same thing, really. It's the same idea. And then there's smart base, which is just us saying, hey, here's you. You've got a station here, 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 and here. You could just use one of these, but that's kind of a waste. What if I just took all of these stations and then just built a virtual station here that represented the correctors from all of these stations, and then just use this VRS, this virtual reference station, to process to get a smart base solution. That's all smart base is. Use multiple stations and you just average out all of these disturbances. And then I ran out of space. And then you have this idea with state-based PPP. So if you look at, maybe I should just do that. I bet if I just completely misspell station, it'll get me to the right place. Somewhere here I think there's a diagram about, like, yeah, check this out. This thing right here. Right? Now we're in the state-based world. In state-based, what you do is you have a lot of money and you run a bunch of stations all over the world, and then you build a model that reflects all of the things that we're correcting for in the differential world, except it's modeled, so it's doesn't rely on real-time data, doesn't rely on in situ, like your station is here, and if that station goes out, we're in trouble because that's the one you're using, right? It's a model that includes all the stations. And so what you do is you're saying, okay, if I'm here, right, and I have a bunch of data, and I got track lines, I'm going back and forth, right? I'm running lines. I'm a survey man. It's my lines. Doing some coverage. What we're going to do is we're going to say, okay, POSPAC, here's my trajectory. This is what the POSPAC view looks like, right? You look at map view. It's just your trajectory. And I'm going to say, POSPAC, I want to do a PPP solution. Just cut me out a piece of that model. Right? This model here. Think of this as like a separation surface, sort of. Right? We're just going to take that, and we're going to cut out that piece. And we're going to download it and use it for our data. That's really all PPP is. And then the last thing you get to is RTX. This is real-time extended. And it's sort of both. They sort of figured out, right? I think this is the RTX brochure. they figured out, hey, let's use these stations. Great idea. Right, we'll build a model. It's resilient. You don't have to worry about a station being up or down or whatever. But we'll extend it by also doing the differential thing. And so they have all these receivers anyway. Let's take all that data, they'll put it on a server they own, and then they'll give you the state-based and the differential and then mix it together in some very complicated procedure that I don't really understand myself. And then they'll cut you out a piece of that RTX model and you'll download it. That's why RTX requires internet. You're sending it a trajectory, it sends you back this piece of the model it cut out. In reality, it's just, it's not a square like this, it just follows a track line, I think. I hope they don't do this. That's kind of a waste. And that's also why you have to wait an hour, right? So that's not a number that we just came up with. That's literally what they say. It's probably in here somewhere. You have to wait an hour. I think it says up to an hour. And the idea is that you have to give it time for data to show up at the server, for it to have enough data to do the differential thing, and then for it to make the data available to you. So when you run pause back and you hit the RTX button, it'll get this chunk ready for you to download. That's how it works. We all lived happily ever after. The end. Good? I can't hear you anymore, I don't think. Somebody give me a thumbs down.
There was a slow clap. So.
Give me a thumbs down if you can hear me. You didn't like it? How dare you? I've recorded that. Alright.
Your Bob Ross skills in MS Paint are impressive.
Yeah, you like that?
Got a happy track?
It's happy little trees. This looks like something you show somebody before they put you away forever. I just had these dreams and I don't know, this is just what it looked like in my head. Lots of lightning bolts and like blood or something. I don't know. Alright. I think that's all I had. Any questions? I can talk about other stuff. I can go on forever. Or I can quit.
All right, questions? No? No, I think that's it.
Okay.
Thank you.
Sure.
QC Tools
Absolutely.
has certainly made our lives a lot easier and allowed us to focus on things that are